Hello and welcome to our AccelByte Development Toolkit presentation. To begin with, we're going to see a general product background, followed by a visual representation of our ADT data structures. We will then do an overview of our build distribution and health systems, our development roadmap for 2024, and what's coming next. Two main problems motivate us to create AccelByte Development Toolkit. The first one is that making great games is harder than ever as the game content is getting larger and more complex. That, in combination with a fully remote team distributed all around the world, makes build distribution a complex matter. The second one is that game developers need productivity tools so they can focus only on what really matters, which is making the game fun, special, and unique. For this reason, we have created ADT, a suite of tools developed to help developers iterate the development process faster, starting from creating the build, distribute the build to the team, arrange the playtest, monitor the health, and then make improvements to iterate again. We have three main areas that we cover with ADT. First one is distribution. Using the desktop app and the command line interface, users can upload and download the build. Second one is health. Users can use the web, the SDK, and the command line interface to track crashes and see device performance profiling from each game session. Last one is playtesting. You can easily create a playtest with the app and then get the detailed report on the website. Let's now talk about data structures. ADT has a linear data structure that starts with a namespace followed by games, games version, builds, then sessions, crashes, and game binary. Namespace can be the name of your studio or any name that you like, and the same for the game. You can have more than one game in your namespace. A game can also have multiple game versions, and one game version can have multiple builds. Users can register the build for each platform that is supported by ADT. It's also possible to create more than one build per platform with different configurations, like shipping or development. The build itself will be the place to upload the game binary and collect sessions and crashes related to it. Now, let's see the concept of the channel. We will use an example of a game studio A working on a game called Byte Wars. As you can see, there are three builds under version 002. This is the Windows build with a development configuration, another Windows build with a shipping configuration, and a PlayStation 4 build with a development configuration. There are also three builds under the previous version, which is 001. Each build will have its own sessions, crashes, and game binary. The channel concept is to group game binaries for a specific purpose, a specific team, or maybe an event. Inside the channel, there's a track for each specific platform. In this example, we have two channels. We have the development channel with two tracks, Windows and PlayStation, which will consist of all the development builds. Q&A can then join the channel, download the build, and do the tests. We have another stable version channel that will only have the stable builds for C-level people, so they can always have access to the latest stable build. We are also able to create a channel for a specific event and use the same build. In this example, we can see a channel called GDC Demo Channel, and it will contain the build that we will use for our demo during GDC. Next, let's see how to upload the game binary to ADT. The game binary can be uploaded using the ADT command line interface, which means you can fully automate the process in your build pipeline. First, we need to create a namespace. This will be handled by our team using your game studio name or any name that you like. The game itself can be created in the ADT web portal, and you will then get the API key. Now, using the ADT command line interface, we need to run this command to create a game version. It requires the version name, your namespace, API key, and your game project folder path. It will create a game version with a unique game version ID. Next, we need to run the command to register the build. It requires the platform name architecture, the namespace, API key, game engine, and the game project folder path. By running this command, it will create a build under the newly created version. To upload the game binary, we need to run the upload binary command. It requires the name of the executable file, namespace, API key, game engine, game project, and game archive folder path. This will add the game binary to the newly created build. Once the binary is uploaded, you can use ADT command line interface to make that build the head of the specific track. For this, we need to run the command track update head, which requires namespace, API key, game project folder path, track ID, build ID or build name, and the version ID or version name. We can also upload the game binary via drag and drop. In this example, we want to replace our Windows build version 001 with the new stable version 003. To do this, we just need to drag and drop the folder to the track. It will go through all the processes of creating a new version, registering the build, and uploading the game binary to ADT, as well as updating the track with the 003 Windows shipping build. The previous build will be kept in the track history, so whenever we want to roll back to the previous version, we just need to check the track history and choose the previous build as the head for this track. Here we can see a screenshot of the new ADT Hub layout. As you can see, we got inspired by Slack, where users can see the channels at the left sidebar and the tracks for each platform inside each channel. Next, we are going to see the build distribution system inside ADT Hub. First, we need to register a new device, in this case an Xbox kit. We set it as the default device. We download the build in a selected location. And then we click Deploy. We are now ready to test. Now, let's take a quick look at our health system. If we select the Crashes tab, we will see the list of crashes with some useful information, like the number of times that the crash happened, number of users affected by it, dates, and status. We can click in one of the crashes to see more details like title, build, and the call stack, among other fields. We can also see the video that ADT records 10 seconds before the crash happens. With this video, we have all the information needed for our Q&A team to reproduce and fix the bug. Another great feature we have implemented in ADT is Jira integration. You can create tickets directly from our hub and fill in the requested fields. It will then automatically attach all the information about this crash as part of the ticket, like the call stack, logs, and video. To finish off, let's take a quick look at our development roadmap for 2024. It's worth mentioning that our roadmap is directed by our customer needs and pain points. As you can see, there are some exciting upcoming features like Smart Build support for custom engines, some UI/UX improvements, and iOS and Mac support, among others. Please let us know if there's something that you think we are missing from our roadmap. Feedback from developers is also welcome, so please don't hesitate to get in touch with us. Thank you and hope to see you soon again.